A CPVC conduit line can be mechanically complete and still fail the buying decision if the material, tooling, dimensional targets, and approval requirements were never tied together. A label such as electrical protection pipe identifies an intended application, but it does not prove that a proposed line can produce the required conduit for a particular market. The purchase should begin with the installed application. Define the installation environment, cable or utility context, conduit geometry, local requirements, test methods, and any project owner approvals before comparing machinery. The product specification should identify the CPVC formulation or approved material range, target sizes, wall thickness range, dimensional tolerances, marking requirements, required mechanical or thermal tests, and inspection frequency. It should also state who accepts each item of evidence and when that evidence must be released. This boundary must remain visible from quotation through commissioning. A broad PVC equipment platform may include an extruder, tooling, downstream equipment, controls, and service support. The finished CPVC conduit result also depends on material handling, temperature control, melt behavior, sizing, cooling, haul-off, cutting or coiling, inspection, and records. The evidence must cover the complete production path. Every supplier should receive the same controlled input pack. Include the conduit sizes, wall thickness range, production assumptions, material conditions, permissible changeovers, utility constraints, installation location, factory test expectations, and required documents. Identify fixed requirements and areas where alternatives may be proposed. This prevents quotations from appearing comparable while relying on different assumptions about resin handling, tooling, output, or commissioning responsibilities. The quality control chain should be equally clear. It begins with material identification and preparation, continues through monitored production conditions, and ends with traceable measurements and sample retention. Records should link each observation to a production interval, operator correction, or agreed response when results fall outside the specified range. Use supplier claims as starting points for verification. A configuration drawing can establish equipment scope. A material record can identify the intended formulation. A factory acceptance log can document operation under stated trial conditions. A dimensional report can show measurements from a sample. None proves the entire future production outcome alone, but together these records can establish a defensible procurement basis. A relevant product page example is Jwell machinery stated offering for UPVC water supply and drainage pipe and CPVC electric protection pipe extrusion. Its information can frame questions about configurations, applications, pipe sizes, output, and power. It should not, by itself, prove suitability for every CPVC formulation or market approval. The buyer should ask which configuration, die, downstream arrangement, material conditions, dimensional measurements, and shipment records apply to the proposed conduit. 7 evidence gates make these questions actionable: material fit, pipe geometry, tooling fit, process control, quality evidence, the FAT plan, and commissioning support. Each gate should be marked pass, conditional, or missing. A conditional item is acceptable only when it has a named owner, a defined document or test, and a committed timing. A general capability statement cannot conceal missing proof. Before shipment, witness 4 FAT checks. Confirm the material and setup, including resin identity, die, set points, and startup conditions. Observe the continuous run, recording duration, stops, alarms, and interventions. Inspect conduit quality through diameter, wall, surface, marking, and the agreed sample plan. Finally, verify controls and handover, including interlocks, operator steps, training, and open actions. The FAT demonstrates operation under agreed trial conditions. It does not replace regulatory approval or a finished system installation test. Release should be recorded as accepted, accepted with named open actions, or not accepted pending corrective or repeat testing. Commissioning must use the released FAT configuration as its baseline. Transfer the configuration record, material assumptions, inspection forms, training record, open action list, and escalation route to the site team. Any change in material, tooling, utility settings, or conduit size should be recorded as a controlled variation. The strongest purchase decision traces every equipment claim to a product requirement, a test method, and a responsible party. that evidence makes configuration gaps visible before they become commissioning delays.